In 1997, NASA sent a radio signal toward a distant star system. The signal was strong, clear, perfectly transmitted. 3 light-years into its journey, it simply stopped existing. Not absorbed, not scattered, not reflected. Gone. As if space itself refused to carry it any further. Since then, astronomers have mapped multiple regions where electromagnetic radiation behaves in ways that violate fundamental physics. They call them the silent zones. Radio waves travel through space at the speed of light, crossing vast distances without losing their fundamental properties. That's how we communicate with spacecraft billions of miles away. Space is an excellent conductor for electromagnetic radiation. There's nothing to absorb it, nothing to block it, nothing to stop it. Until there is. The silent zone sits approximately 300 light-years from Earth, in a region of space that looks completely normal in every other way. Stars shine there, dust clouds drift, gravity behaves as expected. But when radio waves enter this region, something impossible happens. They don't scatter, they don't get absorbed by dust or gas, they simply cease to propagate, as if the medium of space itself refuses to carry them. And it's not just radio waves. The entire electromagnetic spectrum below infrared frequency appears affected. But visible light, X-rays, and gamma rays pass through normally. The boundary is sharp, clean, impossible. The first hint came from radio astronomy surveys in the late 1980s, when astronomers noticed unexpected dark patches in all-sky radio maps. At first, these patches were assumed to be regions of intense radio absorption, like dense molecular clouds blocking background sources. But when optical telescopes looked at the same regions, they saw normal star fields, no unusual dust, no dark nebulae, nothing that should block radio waves. Then, in 1997, the Deep Space Network transmitted a test signal toward a star 300 light-years away. The signal was tracked using interferometry, watching its wavefront propagate outward at light speed. At roughly 3 light-years from Earth, the signal's amplitude didn't decrease. It flatlined. The wave stopped existing. Engineers suspected equipment failure. They repeated the experiment 4 times over 2 years, targeting different stars in the same region. Every time, the same result. By 2003, multiple independent observatories had confirmed the phenomenon using different frequencies, different transmission methods, different targets. The silent zone wasn't a single point. It was a region, roughly spherical, about 40 light-years in diameter, centered approximately 300 light-years from Earth. What made it truly baffling was the selectivity. High-frequency radiation passed through without interference. You could observe stars in visible light, detect X-ray emissions, even measure gamma-ray bursts from beyond the silent zone. But radio waves, microwaves, and long-wavelength infrared simply stopped propagating. The cutoff frequency was sharp, around 1 terahertz. In 2008, the European Space Agency launched a dedicated mission, the Radio Silence Observatory. It carried receivers covering the entire electromagnetic spectrum. What it found was deeply unsettling. The boundary was not gradual. It was a hard edge, like a wall in space, where certain wavelengths simply could not pass. Inside the silent zone, radio emissions from natural sources like pulsars and hydrogen clouds were completely absent, even though those sources were clearly visible in other wavelengths. It was as if space inside the zone had different physical properties. The same vacuum, but fundamentally altered in how it interacts with low-frequency photons. Theoretical physicists immediately started working on models. Could this be altered vacuum energy? A domain wall from the early universe? Exotic matter? None of these models fully explained the observations. Each predicted side effects that simply weren't there. If vacuum energy were different, you'd expect gravitational anomalies. There were none. The silent zone violated physics in one very specific way, while leaving everything else perfectly normal. That precision was the most disturbing part. And then, in 2015, astronomers discovered something that changed the entire conversation. The silent zone was not unique. Using improved radio telescopes and machine learning to analyze decades of archival data, researchers identified 4 more silent zones scattered across the galaxy. Each one had the same properties: spherical, roughly 40 light-years across, completely opaque to frequencies below 1 terahertz, transparent to everything else. Their locations appeared random at first. No obvious connection to stellar populations, gas density, magnetic fields, or any known astrophysical feature. But when plotted in 3 dimensions, a pattern began to emerge. The silent zones weren't randomly distributed. They formed a geometric structure. If you connected them with lines, they outlined vertices of what looked like a very large lattice, extending through this region of the galaxy. The spacing suggested the lattice might have hundreds or thousands of nodes. This geometry implied the silent zones were not natural phenomena. They were too regular, too precise, too carefully spaced to be random products of stellar evolution or cosmic accidents. The alternative was almost impossible to accept. These were engineered structures, built by something, for some purpose, using physics we don't understand. But who builds walls against radio waves in deep space? And why choose that specific frequency range? What possible function could this serve? One hypothesis proposed that the silent zones were part of a communication blackout system designed to prevent radio signals from propagating through certain regions. Perhaps an advanced civilization wanted to keep specific areas hidden from radio detection, creating dead zones where their transmissions wouldn't leak out. Another theory suggested the zones were defensive, protecting something inside from external electromagnetic interference or hostile directed energy weapons. A darker possibility, the zones were containment fields designed to isolate something that communicates via radio waves, preventing it from spreading or signaling. Each hypothesis sounded like science fiction. Yet the silent zones existed. Their properties were measurable, and their geometric arrangement suggested intentional design.
In 2018, a controversial proposal emerged. Send a probe directly into the nearest silent zone to study its properties from the inside.
The mission, called Silence 1, launched in 2021. Its destination? The original silent zone, now 324 light-years away. The probe carried a revolutionary propulsion system, a solar sail accelerated by ground-based lasers to 20% light speed. Even at that velocity, the journey would take over 1,600 years. But Silence 1 was designed to transmit data continuously as it approached the zone. The plan was elegant. Watch in real time as the probe's radio transmissions weakened and ceased, while its laser-based optical telemetry continued unaffected. By comparing the 2 data streams, scientists hope to understand exactly what happened to electromagnetic waves at the boundary. The probe is currently 30 light-years from Earth, still decades away from the silent zone's edge, but it has already begun detecting faint anomalies. Subtle timing discrepancies in its radio signals suggest the boundary might extend farther than originally mapped, with a gradual transition zone. If confirmed, this would mean the silent zone isn't a hard barrier. It's a gradient, a region where space-time properties smoothly transition from normal to anomalous. That gradient structure might be the key. If it's too sharp, you need exotic physics. If it's smooth, maybe known physics with unusual boundary conditions could explain it. Meanwhile, ground-based observations have continued mapping additional silent zones. As of 2024, 17 have been confirmed. The geometric pattern has become clearer. The zones appear to mark corners and edges of enormous cubic cells, each about 2,000 light-years on the side. Our solar system sits inside one of these cells, roughly equidistant from several silent zones that mark the cell's boundaries. If this pattern extends throughout the galaxy, there could be thousands of these cells, with silent zones acting as structural markers or boundary mechanisms. But boundary for what? What is being divided or contained? And who or what built a structure spanning thousands of light-years? Some researchers now believe the silent zones might not be intentionally constructed at all, but natural artifacts of something much larger and stranger. What if our region of the galaxy is inside an artificially modified domain, a zone where space-time has been engineered on the largest possible scales? The silent zones wouldn't be walls in that scenario. They'd be seams, the edges where this modified region meets normal space, creating interference patterns in certain wavelengths. This idea is almost more unsettling than deliberate construction. It implies we've been living inside an engineered environment without realizing it.
Here's what we know for certain. The silent zones exist. They've been independently verified by dozens of institutions using different instruments. Their properties are consistent. Spherical regions approximately 40 light years in diameter, completely opaque to electromagnetic radiation below 1 terahertz. They are distributed in a geometric pattern, suggesting large-scale organization, with spacing and alignment that appears non-random. No natural astrophysical process currently known can produce these characteristics. Every conventional explanation has been tested and found insufficient. The Silence 1 probe continues its journey, collecting data that will be analyzed for centuries as it approaches the boundary. Whatever we discover when it reaches the silent zone will fundamentally change our understanding of either physics or our place in the cosmos. If it's a natural phenomenon, we need new physics to explain it. A new field, a new force, something that couples specifically to low-frequency photons. If it's artificial, we need to accept that something in this galaxy has the capability to modify space-time on scales of tens of light years. Either answer is profound. Either answer changes everything. There is no comfortable explanation for the silent zones. And there's one more detail that keeps physicists awake at night: the boundary frequency. 1 terahertz sits right at the edge of the radio spectrum. It's almost as if the cutoff was chosen deliberately to block radio communication specifically, while leaving all other wavelengths unaffected. That precision doesn't feel like a natural threshold. It feels like a choice. It feels like design. For now, the silent zones remain one of the most profound mysteries in modern astrophysics. Documented, measured, but unexplained. They don't threaten Earth. Our region of space appears to be well inside a normal cell, far from any silent zone boundaries. But their existence challenges everything we thought we understood about how electromagnetic radiation propagates through space. Every physics textbook says electromagnetic waves propagate through vacuum, according to Maxwell's equations. The silent zones say otherwise. Maybe Maxwell's equations are incomplete. Maybe there are additional terms, additional fields, that only become relevant under specific conditions we haven't identified. Or maybe the vacuum itself isn't uniform. Maybe space has properties, variations, structures that we've never detected because we've only sampled a tiny region locally. The silent zones might be showing us that space is far stranger, far more complex than our local measurements suggest. Some researchers now argue we should be searching specifically for other anomalies, other regions where physics behaves unexpectedly. If the silent zones exist, what else might be out there? Zones where gravity behaves differently? Regions where light travels at different speeds? The universe might be full of these anomalies, and we've only just developed the instruments and observational reach to start detecting them. Whether by natural processes or deliberate engineering, something is changing the fundamental properties of space in localized regions. And if it's happening in our galactic neighborhood, it's likely happening elsewhere. The silent zones near Earth might be common throughout the universe. The silent zone is a reminder that for all our scientific progress, the universe still holds mysteries that defy our understanding. We've mapped the cosmic microwave background, detected gravitational waves, imaged black holes, and yet we can't explain why radio waves stop in certain regions of space. Maybe the answer is new physics. Maybe it's ancient technology. Maybe it's both. Maybe it's something we haven't even imagined yet. What's certain is that the cosmos is stranger than we thought, and the silent zones are proof that even in the vacuum of space, there are places where the rules change. Out there, 300 light years away, space itself refuses to carry the signals we send. And we still don't know why. If you want to explore more mysteries at the edge of physics and human understanding, subscribe to Parallax. The universe isn't finished surprising us yet.